Hello, everyone. Good morning, good afternoon, good evening, wherever you are. We are very excited to bring you this session of Citrix Converge 2020. The session is about how to use a Canary operator for microservices to upgrade or to migrate your Kubernetes clusters. And I am Komal Bhardwaj. I am one of the presenters of this session. I work as a product manager with the app delivery and security component or app delivery and security business initiative in Citrix. And I have with me Raveendra and Mayur, a part of this session speakers. Raveendra, would you like to introduce yourself?
Hello everyone, I'm Raveendra Holla, Principal Engineer here, working in Citrix for last 15 years. I'm working in Cloud Native Stack recently.
Hello everyone, my name is Mayur Patil. I am Senior Product Manager in Citrix. I have completed 3 years in Citrix and working in the Citrix app delivery and security domain.
Yeah, thank you, Raveendra. Thank you, Mayur. And so let's get started with the session details. As you can see that the agenda is about what are Canary deployments. We'll talk about Citrix multi-cluster Kubernetes solution. And then specifically for this session, what we have done is the third and the fourth part, where we'll show how you can build a Canary operator for Kubernetes, and we'll do a demo as well. There's a lot of code, a lot of geeky stuff here, so we're very excited. And we'll also talk about this is just a MVP. We'll also talk about how you can take this into production and what things you can do to make it a production-friendly solution. So we'll start with what exactly are Canary deployments. So Canary deployments are actually not something which started with the software development world. It is coming from the mining industry, where actually till 30 or 40 years back, coal miners used to use a canary bird to check whether the new mines that they're about to go into, are they filled with poisonous gases or not. So the canary bird is more sensitive to these deadly colorless and odorless gases like carbon monoxide, etc. So if they go and the canary bird's health is not well, then the miners know that there is danger and you should not proceed ahead. So the same concept has been used in the microservices world, where we are using Canary deployments as a CICD strategy, more on the deployment side, CD side. So before going into what these Canary deployments look like, we want to understand where and why these Canary deployments are used. As you can make out, some of the benefits of using Canary deployments is that it reduces the blast radius for any new change that you're doing on production. You can start with a small incremental change and then see what its impact is. You can also see what is the impact on user experience of your new changes, and it gives you the flexibility to roll back or roll out the new changes in production at your discretion. Some of the exact use cases where you would use a Canary deployment is, let's say, if you want to launch a new app or a new version of an app, or you've done some bug fixes and you want to make sure that things are working fine on production. If you are upgrading your infrastructure, let's say upgrading databases or Kubernetes version itself, then you can use the Canary deployments. Or if you are bringing up a new availability zone or a point of presence, or if you are really charting on new territory, like going to a new cloud altogether, or starting with the hybrid cloud deployment, such as Azure Outpost, Azure Stack Hub, or AWS Outpost, or Google Anthos kind of deployment. So you can use the Canary deployment to get your feet wet and see if everything is working fine or not, and then incrementally increase the traffic on the new app or the new infrastructure. So how this looks in practice is quite simple. We'll start with this. We'll keep using this example throughout this session. So I want to make you familiar with this. So let's say you have two VMs or two Kubernetes clusters. One is red, the other is green, and you are using a load balancer to route traffic in a equal proportion among these two. And now you want to introduce a new VM, or let's say a new Kubernetes cluster, which is the blue cluster, and you want to see whether this blue cluster is working fine, it is taking load based on your expectation or not, things are working fine. So what you will do is slowly increase the traffic on this blue cluster. So as you can see, the distribution of traffic is now 45% to red, 50% to green, and 5% to blue. And if things work out fine, let's say you're taking some, you're measuring some metrics like how many HTTP errors are coming, how many TLS handshakes are happening, or how many TCP sessions are dropping, or some other business metric that you want to see. Let's say if the number of page views or the number of conversions is not dropping a lot. So then you can keep gradually increasing the traffic on the blue cluster, and you can again measure these metrics. And this duration can be as small as 1 minute or as large as, let's say, a week. So you can keep observing things for a week on the blue cluster and say the things are working fine. Then you keep increasing the traffic, and then you can eventually phase out the old cluster, which could be, let's say, on an older Kubernetes version, or it could be on an older architecture as well. And you want to, let's say, move to a new architecture. So this is how your new clusters look like. So this is the simple concept that we are going to demonstrate. We are going to go deep into this. So before we show the demo of our exact multi-cluster solution, I want to tell you what is available currently with Citrix ADC for multiple clusters. How do you do this basic routing of ingress traffic across different clusters? So we are not talking about the ingress controller for a particular Kubernetes cluster. We are now talking about a higher level entity which will route traffic across multiple clusters. So before that, a quick overview of what Citrix cloud native solution looks like. This is so if you are running any microservices on Kubernetes cluster, then you can use a bunch of containers which have a very specific role inside the Kubernetes cluster, such as CPX is your containerized load balancer. The ingress controller configures the ingress rules on the ADCs, and then there are other containers which do a specific job. And on top of that, we have the traditional ADCs, SDX, MPX, which do the HTTP, TCP, traffic management, TLS offload functionalities. And what we are going to focus on is the multi-cluster solution, where traffic can be routed across multiple clusters. So how this is done is explained in this new topology. We wait for the slides to come up.
This conference will now be recorded.
Okay, so this is the multi-cluster solution from Citrix. So let me help you understand this topology. We are taking again two Kubernetes clusters. One is the red, the other is the green. They could be same. They could be like exactly delivering the same applications, just that they are deployed on two separate infrastructures or across two availability zones on a public cloud. So how this currently works is that you will have a GSLB or a ADC which will help you in routing the DNS traffic. It will behave as the ADNS for your domain, and the multi-cluster controller that you see in the small red and green boxes. This is the Kubernetes pod, which is responsible for configuring the ADC to keep it updated with the health of the microservices which are running inside the cluster. So let's say if one app goes down in the red cluster, so then this MCC, multi-cluster controller, will tell that the health of this application one is not good in the cluster red, and no DNS traffic will be routed to the red cluster. So how it does this is through a GTP config. GTP is the Global Traffic Policy Configuration. I'll show you the code in the subsequent slides, where the GTP config is sent to the ADC, and the ADCs then sync up between themselves so that they know which app is healthy in which cluster, and then the HTTP traffic can be appropriately routed. Okay, so the end user sees that this is the route. Either they go to green or red cluster, but the focus of this session is on the DNS traffic. So we will not talk a lot about the HTTP traffic, but just for your reference, that this is how the overall architecture looks like. This is a sample manifest for the multi-cluster controller. As you can see in this, we have specified what are the regions, what are the site names. The site names in this case are red and green. It could be your East US or West US, things like those. And we have also mentioned the other details about the about the credentials to log into the appropriate ADCs. And this is the GTP configuration that I was referring to earlier, where in this it's very simple. We are saying that the algorithm to use to route the traffic to a particular cluster is round robin, and there are just two clusters here, and the weights are 1 and 1, which means 50% of the traffic will be going to these clusters, and it will be looking for a TCP monitor, where if the status of TCP response TCP monitor probes is fine, then it will consider that this application is healthy in that particular cluster. So this is something which is available on the product right now. You have the links of the resources available, and we'll share these links later as well. So what we have done as a part of this session is to build a operator on top of this, a Kubernetes operator on top of this, which automates this flow of changing or giving traffic to a new cluster gradually. So you'll see that the operator does an automation that it will begin with 5%, and then it will check for whether the metrics are good or bad, and then it will slowly keep increasing the lever of traffic for the new clusters. So now we come into the heart of the presentation, which is to demonstrate how this Canary operator can help in the multi-cluster ingress solution. So starting with the same topology, with the red and green clusters having their own multi-cluster controllers and their own ADCs for doing the DNS routing. We now come up with a new cluster, which is having the new application code, or let's say the new Kubernetes version. So maybe the red and green ones are on Kubernetes 1.15, and the blue one is on 1.17. So you want to see whether the 1.17 cluster is working fine as per your expectation or not. And as you can see, the multi-cluster controller for the blue controller is for the blue cluster is also configuring the red ADC, and this red ADC propagates its config to blue and the green ADCs. So this is how all the three ADCs which are doing the multi-cluster routing are in sync. As a part of this session, what we have done is we have introduced a new element called the Canary operator. The Canary operator is a new container which will run inside the Kubernetes cluster, and it will keep measuring some important health metrics, and then it will gradually change the configuration of the GTPs. So we are deploying this Canary operator in all the 3 clusters, but in the blue cluster, since it is a new cluster, we are keeping it in the broadcaster mode or in the teller mode, and in the other 2 clusters, it is in the listener mode. So the red and green clusters, they listen for the change for the configuration details from the blue one now. And the blue one initially will be saying that, hey, the traffic proportions are 50% to red, 50% to green, and 0% to blue. So this is the current state. And then the Canary operator will propagate a change across the 3 clusters. It will say that change 5% traffic from red to blue. Okay, so this configuration will be propagated by the Canary operator through the GTP config. I'll show you the code in the subsequent slides. So this change will be propagated to the red cluster, and which will then auto sync across all the 3 clusters. And then after, let's say, after 2 or 3 minutes, it will observe some metric. It could be your HTTP 500 metric, or it could be how many TLS handshakes are going through fine. And then it will keep changing the metric to higher number. So it will, let's say, change it to 10% to the red cluster, and then 40% to the blue cluster. And slowly, if things work out fine, then the red cluster will be phased out, as I was explaining earlier. So this is how the Canary CRD looks like. CRD stands for the custom resource definition, and this is a new development work that we have done as a part of this this session. And as you can see, the GitHub repository is one of our repository. It's Raveendra's repository, in which you can see this code. And here we are saying that the health monitoring interval is 20 seconds, and the threshold is 90% for a metric. And the 2 clusters, the source cluster is the red cluster, and the destination cluster is the blue cluster, where we want to migrate all the traffic from red to blue. This is the configuration of the Canary operator in the broadcaster or in the teller mode. These are the details of the blue clusters, and this is the detail of the Canary operator in the listener mode, where this is deployed on the green and the red clusters. So with this, I will hand it over to Raveendra now, so that he can give you the demo of the product, of the operator that Raveendra
Thanks,
has.
Komal.
Yeah, Raveendra. Raveendra, we can hear you. We can start with the demo.
Thanks, Komal. So as Komal pointed out, for the demo purpose, we have 3 clusters. To start with, we have a red cluster, right? Just to name that red. So it is running app 1, and then CIC is running. CIC will expose this app at a cluster level, whereas multi-cluster controller take the responsibility of exposing this app across clusters. Okay, it works on the GSLB, uses the GSLB solution of the Citrix ADC. Both may or may not configure same device. You can make sure that both can be same devices. So similarly, we have the green cluster, which also have the same pods running. You can see that app 1 is running, CIC is running, which is exposing the app at this ingress level for this cluster, and this is synchronizing across the cluster. So how the GTP, which is the global traffic policy, may look like, right? It should be same across all the clusters. So let's see that. So if you see that, I have shifted the traffic policies to Canary now, and I'm saying these 2 destinations should take the same amount of traffic, right? Region 1 red and region 2 green clusters should take equal amount of traffic. So let's see how the DNS resolution is working. So I'm running in a loop here. You can see that this IP 143.150 represents the public virtual IP for that app1 on red cluster, whereas 170.35 is basically the public VIP IP on which the app1 is exposed on the green cluster. So when I do a dig on this, so I'm getting the kind of the resolution is resolving to one of these IPs more or less with a 50% one. So now we can go to the blue cluster, right? So this is the latest cluster. Whatever reason, this is the latest Kubernetes cluster. We want to see how the app works, right? So I set it up now, like yeah. So pods output is available here. So the app one is running here as well now, and CIC is also running, right? For whatever I have to run the node controller for connectivity for this cluster with the ingress, and the multi-cluster controller is running. But only thing is the GTP here as well, right? Should be same, okay? You can see that it is still only 2 clusters. Even the service is up, this is exposed on a VIP on this blue cluster. This one. So now, now what we are planning is a Canary deployment. For that, what we should do is that any GTP changes done here has to be propagated to the other 2 clusters, right? So what we will do is we will install a listener mode Canary here. Okay, so how I think Komal has shown that. Just I will show again. See, this is a Canary listener mode. So here all are same, but we need to give the external Kubernetes URL, which is the URL of the new cluster on which the modifications will happen. It has to listen for that, and we need to give the token as well. Token should be give the privileges to listen for any changes to global traffic policies. Okay, so let's start it. So let's check the logs. Yeah, that's fine. So now the pods are ready, and it is waiting for any changes to the remote GTP. Similarly, we will have to install in the listener mode on the green cluster as well. Same definition. Okay. So I have created on both the clusters. Let's check the. It is running now. Check the logs. Good. So this is also listening. Now we come here. Okay. So here, this is the blue cluster where the core logic here, the Canary will run as a teller mode. Okay. This is the core logic is here, which modify the GTP, apply the GTP, and check for the counters. So for example, if you see as shown by Komal, we are going to apply this here. Okay. So what it says that give a 20 seconds interval. We are keeping a short interval for the demo purpose. This is the LBV server which represents this service app1 on this cluster's ingress. Okay. Look for LBV server statistics here and calculate the health threshold. This is an abstract score, health score. We have used the simple logic, and based on the requirements, we should be able to extend this health score calculation. But whatever you calculate, if it is more than 90%, it should go for next percentage. Okay. So now what it says is we want to move the traffic 50% of the DNS resolution happening from red we want to move it to blue. Okay, so let's create. So this is a teller operator deployment. Okay, I created just to show that, right? It uses same image, but the mode is teller. These parameters are the parameters used by the teller to verify the statistics right now. Okay, this is where this IP and this one. So it will get the LBV server statistics from there. We'll check the logs here.
Which statistics are we using to take the decision on to roll out or roll back?
So right now it is we are taking, like, we take the snapshot before and after between that interval and compare the number of requests served, and if there are some failed counters, so request minus failed into 100 divided by total requests. So that's the percentage it calculates in this one. That logic can be improvised. Right? So now it is watching for any Canary CRDs. So let's we are ready to apply the CRD now. Okay, so now we'll check the log, what it says. Okay, so it received a Canary CRD for app 1, So it has increased the percentage to 5%. What it means is that if you see now, it automatically updated the YAML percentage changes it has done, and it is keep monitoring. So let's come back to the log. So it is going good. So it is increasing to 10%. And if you come here, you can see that the GTPs are synced here. He is also getting the GTPs from the blue cluster, the changes, and he is creating the same here. If you see here on all the other crystals, see, he is showing the change in the percentage. The same thing is here as well. So all the remaining cluster which are in the listener mode are synchronizing. So let's see what is happening now. See now. So the new IP which is also start getting resolved. So 37.175 is from the blue cluster. But we see the deep virtual server IPs from all the 3 clusters now. Because see this 170.35 from the green, which will continue there, but the 143.150 and the 37.175, right? So those are this one, but the proportion will be defined by the new Canary, which is getting, to say it increased to 50%, 30% now. So every 20 seconds it checks the counters and see that it can go over that. If it sees a failure, it will roll back to the original state and update the logs.
So, Raveendra, can you tell us what is the IP of the blue cluster?
So the IP of the blue cluster is 10.102.37.175. Okay.
So 175 is that the 175 proportion will keep increasing, and the red one is
right.
Red one is
that has reduced now. This is a 10.106.143.150. That is going down now. Number of so now more or less the dig output shows only IPs from the green and blue clusters, right? Because we are kind of close to the So now the last the percentage has increased. Let's check the final GTP, how it looks like after this one. So it has increased the percentage to 50%, but it's still monitoring it. So once it is done, it will say that the migration is successful. Okay, so we'll stop the, like we're seeing the log so far. So let's see how the GTP looks like. Great. So it moved from the red and green to green and blue using the Canary mode. And same thing is across is seen here. All other clusters also has moved to 50% thanks to the listener mode one. So you can see that. So this is also moved to 50%. So now you can see that our dig output is only focusing on the IP 170.35, which was from green, which was there before also. But now 37.175 is coming from the blue cluster. So the app one is no more accessible from the red cluster. Thank you. This is from the demo part.
Thank you. So Raveendra, can you also show the code that you have written? Just walk through the GitHub repository.
Okay. So this is the repo right now. So we have written the operator in the Python framework. Okay. So you can see all the source code here. The single mode and all the deployments which we covered here are added here. More documents, what are the RBACs required, etc., are added here. So we'll add more documentation so that you can try out.
Thank you.
Easily.
Thanks a lot, Raveendra. So to conclude, thank you for such a good demo, Raveendra. And Mayur, can you tell us about what are the future possibilities with this Canary operator?
Sure, Komal. Thank you, Raveendra, again for a very wonderful and exciting demo. So let's see what are the future possibilities. There is always a scope for improvements, and we rely on improving our product. So as you have seen in our demo, we have done and taken the decision of rollback and rollout on the very basic metrics as explained by Raveendra. But we have few other metrics, advanced metrics that we can think for taking this decision, such as the Prometheus metrics coming from ADCs or the applications. This can be a very fruitful source for taking the decision when to roll back and when to roll out your next cluster. Along with that, you can also rely on Kubernetes API server health metrics. And you have application HTTP, TCP codes, which is also one of the candidate for taking the decision. Plus, in this demo, the Canary operator is running as a separate container in the Kubernetes cluster. However, we can make this Canary operator as a part of multi-cluster controller that you have seen in the topology. For you, we have brought very exciting collaterals that you can refer, starting from the GitHub repo that Raveendra was mentioning. So the current demo that he has shown to us is available in the first link of GitHub repo, where you can right away go to this link and do the testing of what we have shown about our Canary operator. Apart from that, we have multi-cluster ingress solution, which is Citrix production feature available, and it is residing in our developers docs, where we have demonstrated what is a multi-cluster story for the Citrix, how you can implement that, and along with some hands-on example. Plus, whole picture about the Citrix cloud native solution is provided in this landscape, which is the third link. And also, if you are interested to do more hands-on, we have created separate GitHub repo called as Cloud Native Getting Started Guides, where we have added bunch of examples for beginners, for advanced, for all the different use cases that Citrix is supporting as a part of Cloud Native Story is available under this repo. And as Komal was also mentioning about Citrix Ingress Controller, we have separate examples repo available for this repository for this feature, which tells you how we are configuring the ADCs and how it is communicating to the Kubernetes API. And last but not least, entire portfolio about Citrix ADC documentation is available in the last link. So just to conclude, I would like to say that the current multi-cluster solution is available in the production right now. And in this session, we have built this simple operator, which is doing the Canary deployment. So developers, those who are interested to build their own operator, can use this platform and create their custom workflow. So I would request, please use this Canary operator and the Cloud Native Getting Started guides to understand our product very well. Thank you.
Thank you, Mayur. Thank you, Raveendra. Thank you, everyone. Have a good day.